My name is Tabo Ibrahim Traore, your technical manager for the 24-25 season. And once again, thank you for joining us this evening. I'm aware a lot of people are in Birmingham right now or preparing to, so I understand why the attendance is low. But again, if you're here, thank you for joining. But don't forget to RSVP if you haven't already done it. Or you could drop your name and email in the chat if you didn't do it before, and that will help us keep track of who is joining us. And yeah, we need this because, uh, excuse me, we'll be handing out prizes later on, and for many other reasons. Now today we are going to be looking at stacks and queues. These are important, very important concepts as well. And it's very important to know them in programming because you're gonna use them later on. Yeah, so now let's break down the theory. But before we do, if you don't have lead code, I suggest you get it. But at this point, if you've been attending regularly, you should have it. Let's go right into it. What is a stack? So in plain English, a stack would be like an arrangement of items in which one is over the other, like they typically go vertically, they rise vertically. And that can be like represented in the image there of the books, like that's a stack of books because like they're one is on top of the other, like that's how they're arranged. Um, Now, if you notice that same stack, if we want to reduce our chances of like not dropping the whole stack, the best way would be to take off from the top and like read the book. And this becomes more important like the longer the stack gets. And that's basically the principle with stacks. So, uh-oh, yeah, more technically put, a stack is a collection based on the principle of adding elements and retrieving them in the opposite order. So what that means is that going back to this type of books, like when we're putting these books in this order, we always start with the one at the bottom, going all the way to the top. But if we wanted to remove them, we'd have to start with the one at the top, going all the way to the bottom. I wish I was able to whiteboard to make it make sense, but I hope it's making sense at this point. So when adding like to the stack, the first item you put is the book at the bottom. And then when removing, and the last one to be added is going to be the one right at the top. I think that's yellow. Then when taking them off, you have to start with the one at the top, and then the one at the bottom is going to be the last one to be, let's say, accessed. Um, yeah, so that principle is known as last in, first out, or LIFO. And it basically means the most recently added element is the first to be removed. So the last one to be inserted is the first one to be outputted or accessed. And for for these, the client can only add, remove, or examine the last element at the top. So the last element is what we have access to. You can add it many times as you want, but when you want to start doing processing, you have to like work from the back. So the basic operations for stack are like push, which means adding an element to the top of the stack. And when we say top of the stack, what I want you to kind of visualize is the end of the list because we mentioned that stacks only operate at the end of the list, right? So, I mean, we only access the element right at the end, right? So, um, can I edit this? I can't edit it, unfortunately. But we know that typically lists in Python are horizontal. But like if you look at that stack, it's vertical. And we apply the same principle. So we assume that the list that we use in Python is, let's say, rotated 90 degrees such that it's vertical. And the last element is at the top, and the first element is at the bottom. So index 0 is right at the bottom, and the last index is at the top. And that's what we really mean. So first becomes the bottom, and top becomes the last element. So yeah, that's basically what we mean. Then popping basically means removing the top element from the stack. And if you've used lists before, you might be familiar with how popping works. Then is empty checks whether the stack is empty or not. Now in Python, we don't really have this functionality, but we could like uh, imitate it. Yeah. So that's a little bit about like stacks on a theoretical level. I hope in the breakout rooms you're going to be able to like go further into these concepts. Now for a queue is simply a collection that retrieves elements in the order that they were added. Think of a restaurant. Like usually the first person, I mean the earlier you like order, the earlier you get. So like the first person to order will be like the first person to get their food, and the last person to order is gonna be the last person to get their food. Same way for voting, the first person to make it in line votes first. And on that note, you guys should vote too. If you can vote, vote. But just a side note. But yeah, you're gonna if you do vote, you're gonna be implementing that you're gonna be in a queue. So they operate in the principle of first in, first out. That is, the first element added is the first to be removed, accessed, or processed, anything. So that's what queues mean. But in Python, it I want to mention that we have something known as a deck queue, which is a double-ended queue, which is a bit funny, and I'll talk about that in a bit. But then for queues, typically the client can only add or technically put in queue elements to the back of the queue, and only the queue which is removed or examine the elements from the front. So like the place where you like add to the list or the queue is different from the like place where you like access the element that you're working with. Um, what I mean by that is like typically we add we add at the end by maybe appending or any like form of like manipulation or functionality we can use on the data structure we're using. But when we want to like actually start doing the work, we access the element at index 0 or the first element in our data structure or list if we're working with a list. So yeah, first in, first out. Yeah, now for the deck queue, the rule is a bit more flexible in that you can add or remove both elements from the back and the front. Like, just like the name suggests, it can be a queue from left to right and right to left all at the same time. So you can add at the beginning you can add and remove at the beginning, while you can also add and remove at the end. So I'll speak a bit on that, but I just added this to say that the first rule does not always apply. So yeah, the basic queue operations are basically adding and removing. And then of course we have to process. So when we add an element to the block of the queue, that's in queue, we call that to in queue. Then when we dequeue, we remove. Um, yeah, now in Python we have many types of queues. I'm only gonna like talk about these two because these are the ones you might see more. But then I listed others in the next slide, which I hope you're gonna read more on, but I'm not going to due to time. But the first type are lists, which are like the basic queue implementation. This is what you use more frequently, but then, well, I wouldn't say more frequently, but you would definitely come across a question that may need to use this. So yeah, so this is just the everyday list that you use in Python. So like you can use this list to like mimic how queues work, and then yeah, to add to the end, you could append. Um, and then we said when we're adding in a queue, we're calling it in queuing. And then when we want to remove, we pop at index 0. Now, this method is inefficient in that we know that lists have indices. And if let's say I took off like the value at index 0, so that has a gap that needs to be filled in. So index 1 would have to shift to index 0. So every single element in the list up to the last one is going to have to move one place to the left. So we find that inefficient because we'd have to like access each and every other element just because we wanted to work with one. Now that's where the collections.the queue or the double-ended queue comes in handy because it's more efficient for such techniques. And this is why it might be a preferred approach for like most solutions. So for this one, it has the same append and pop. Of course, they're written a bit differently, but then theoretically it's the same thing. So you can add to the end. You can also add to at the beginning. You can remove from the end. You can also remove from the beginning. Um, you can, and then yeah, you can fast append and pop from both ends in an O of one complexity for like adding and popping left. So this basically means that compared to the list, which would have to like cause some movement in the other elements, when we like when we add or remove in the double-ended queue, it only affects what we're working with, nothing else, not the other elements in the list. So it's ideal for most like queues that we're gonna be working with, and it can also be used as a stack. Not typically advised, but if you can justify it and you can understand it very well, you go ahead and do it. Um, yeah, then the others are these right here. I won't speak on them mainly because you may not come across them, but they're good to note. So if you're interested in like reading about them, this document will be shared with you and you can like read more about them. Then I should have mentioned it. I should have put some QR codes there. I forgot to do that, but I will definitely get to that um before I send the summary. But that's really it about queues. And typically that's all you need to know to kind of understand how they like work theoretically. But I mean the waiting. Um but like typically what we want to do is understand them in a way that we can explain them to someone before we can actually look at them in code, because that will help you like think through your processes. Now, time for breakout rooms. And I noticed I entered the room. That might not be me. Today we're only gonna have one room for because we don't have enough people, and we are gonna be looking at valid parentheses, except removing remove or adjacent duplicates in the string. And actually, instead of using a breakout room, we could just like stay here, and I could pass it on to Sunday if he's able to take that. We could like do valid parentheses, and Sunday, if you're ready, I could pass it on to you.
Right, let me quickly put the VS Code collaboration.
Okay.